All right, Chan, physics. It's Friday. Congrats on making it to Friday, your first week after spring break. Just wanted to go do a quick video before you work on the worksheet that you have in front of you. So first of all, I have up on the screen two circuits. The one is one battery with one light bulb, and the second is one battery with two light bulbs. And the first thing that we should notice right away is that the light bulbs with the circuit with two has light bulbs that are really dimmer than the first one. And if we think about the way that we think about electricity, that there's electrons flowing around, right? That they're tired right here, they gain 9 volts of energy, and then they're going to lose 9 volts of energy. Well, then it would make sense that in the second one, we're going to gain 9 volts. Then when we come around here, we can only lose 1.5 volts or 4.5 volts because we're going to have to lose 4.5 volts here as well to make up the 9 to get back down to where we're dead tired again. And then we can gain our 9 volts and then lose 4.5, lose 4.5, and then come back again, right? Whereas in this one, we can gain our 9 volts and we can lose all 9 volts in the same bulb. And so there's going to be a lot more energy to make light and heat in the one bulb and not the two bulbs, okay? And so there is just an obvious explanation why there's less light here, okay? But we're gonna then see if we can move forward with, sorry, here we go, what we call Ohm's law. So here we have the example. We've got one bulb, one battery. It's really, really bright. We got two bulbs, one battery. They get a little bit dimmer. We got 3 bulbs. Now we're going to even get more because we're going to share the battery strength across 3. So we're going to see that this example then can be used and put into an equation. And that equation is what we call Ohm's law. Now, a lot of high school physics teachers love to teach Ohm's law as I equals V divided by R. But you guys will see in my class that we're going to use the equation. It's the same equation. We're just going to rewrite it as V equals I times R. All right? And Ohm's law can be written in any number of different ways, but V equals I times R makes our life so much easier when we get further into circuits. So Ohm's law is V for volts or voltage equals I for current. Now that's really strange, right? Because most of the time our letters mean something that are close to what they are. And so I has no connection at all with current, C, but they've always used I for current. And so I means current times R, which is resistance. And so you can see in this little sheet right here that you have the beginnings of the sheet that I gave you, and that is V is in volts, resistance is in ohms, and current or I is in amps. And now all those ideas right there will basically answer the entire front page of the sheet that I've given you. Okay, so V equals I times R, and I is one of those things that I have told you if I was to call you at midnight and you were dead asleep, and I would say, "What's Ohm's law?" By the time we're done, you'll be able to say V equals I times R. It's just going to come out. We're going to use it so many times that you guys are going to know it. All right, so it's a real simple equation to use. We can use it with the 4-column method. So if they have this idea, determine the current in a circuit that has a resistance of 40 ohms and a voltage of 5. Well, we can revert back to what we know, and that is the 4-column method. So we can write down, so I got to get my pen working here. We'll make orange. We can write R equals 40. All right, and then voltage, V equals 1.5. And then they want to know current. So I is equal to the question mark. All right, we'll write down the second column, V equals I times R is our equation. So that's our equation. And then we'll substitute, which is 1.5 equals I times 40. Okay, and then all we'll need to do then is divide by 40 on both sides to get our answer, because this will go away and we'll get I is equal to whatever 1.5 divided by 40 is. And that is as simple as it gets. And so you'll see that there's a number of problems on the flip side of your sheet where you're just going to have to do a quick 4-column method with your new equation, V equals I times R. All right, I think that we just have one last idea to get ready for the next couple days. We have been playing with batteries, and batteries provide us with a certain amount of current. It's called direct current. And we can touch them and we can play with them, and everything's okay because we're not all that worried about direct current and the voltages that we're playing with, 1.5 volts. But the reality is that electricity is dangerous. And so if we look at this chart right here, electricity coming out of the plugs is different. Okay, number one, it's 120 volts. And we have batteries that are 1.5 volts. So when we think about voltage, voltage is painful. It shocks us and it makes us feel that in our system. But it's current that kills us. And we can hardly ever get a current up to anywhere near dangerous levels with a battery and the materials that we have in the classroom. But everything that comes out of the plugs in our houses and in our schools is deadly. The truth is, a house can give up to 15 amps of current. So a plug in a house can give up to 15 amps before a security or a protection system comes in. But you can see from this chart that all it takes is 0.01 before we can feel current. And at 0.01, we're going to have pain. And at 0.1 amps, so still well below what's going to come out of there, we have extreme difficulties. Our body stops working or we can't breathe. We have labored breathing. We have this thing called severe shocks. We get burns and things like that. And once we get over 0.1, we're talking about death. Our heart stops beating. And so you can imagine that if our plugs can give up to 15, which is way up here, that current is just completely deadly. And so we never touch anything coming out of our plugs. And when we get further into this, we'll talk about how our houses protect us from just ever accidentally getting to that point. And they actually protect us and shut off the electricity before we can hurt ourselves. But those are things that we're going to leave for next week. Please, please, please finish the sheet. It's just real simple. The first page should take us about a minute. And the second page is just really V equals I times R over a couple different ways. You should be able to complete that sheet really, really quickly and be masters at Ohm's Law by the time you come in on Monday. I hope you have a great weekend. I hope that we've won the Knowledge Bowl meet. And thanks very much, guys. Have a great day.